Okay, guys, so today we're going to talk about reflection of parent functions. Yesterday and the day before, we kept talking about translation. Remember that a translation of a function is kind of like on translating a geometric transformation or a point. All you're doing is it's part of the geometric transformation. You're moving things left or right or up and down. Today we're going to talk about reflection of geometric transformation. On the screen you'll see this formula. This is a very important formula because it basically is the directions on how the parent function was moved. A quick review from what we talked about in the previous day. We're not going to talk about today. We'll do that next week or whenever we get to it. This is the stretch or shrink factor. In other words, we call that the scale factor. H would stand for this would be basically letting us know that this will be the horizontal shift. And then K would be your vertical. And then more importantly, this right here tells us that this is the parabola of the parent function of y equals x squared. So on the screen, you see the parent function is in black, and then the red is its image or its part of the family. So it's already been transformed. This would be a reflection across the origin. So let's get right to it. I do want you to get this example down. Y is equal to the absolute value of x. The first thing you want to do is always sketch the parent function. So since this right here, the parent function for this will be y is equal to the absolute value of x. We're going to sketch it and let's keep it black. So we know that the parent function of y equals of absolute value of x starts at 0, 0. And then it goes up 1 over 1, up 1 over 1, because this is an absolute value function, so every time you input an x value, you get its positive, or your magnitude away from 0, and right away we know that this parent function looks like a v. So all I gotta do is start here, and let's not do it in white, guys. Let's do it in black. There you go. And that's the parent function. So when you have y is equal to negative x, all you have to do is, if you're not really sure this whole negative on the outside, remember that the coefficient, if it's just negative, it's a negative 1. Kind of like if you have negative a, that's the same thing as saying negative 1a. We just choose not to write the 1, the negative 1. Okay, so you can quickly build a t-table if you're not too sure of when the absolute value of x is negative. So I'm going to build negative 1 times that's the value of x, and I'll get my output. So if I input 0, naturally that would be 0. If I input positive 1, negative 1 times the absolute value of positive 1 is equal to, well, here we have 1 times 1, the absolute value of 1, times its negative 1 is going to be negative 1. Let's do negative 1. If I input negative 1 into my t-table, same thing, negative 1 times the absolute value of negative 1 is also going to give me negative 1, because the absolute value of negative 1 is positive 1. Multiplied by negative 1 will give me negative 1. So basically, if you kept doing this, you will have no longer a v, but what you have is this reflection that looks something like this. It will be flipped over from where it was originally. It would just sit at 0, 0 because that's the vertex at 0, 0 because this has no x or h, so it didn't move up or down or diagonal. And then we just have its reflection over the vertex itself. So it should look something like this. And the equation for the parent is still y equals x, but the equation for its image is now y is equal to negative times the absolute value of x. Okay. So let's do one more. So this one, right away you should be asking yourself, what is the parent function? This one has a square, so it will be a parabola. So we know that a parabola starts at 0, 0. Let's keep the colors consistent. We start at 0, 0, and then we'll go over 1, up 1, over 2, up 4, over 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9, over 4, up 16. So it'll look just like that. you can quickly draw this like this based on reflection properties. Just count away from the y-axis because so this is a curve, it's not really a V. Okay, and then what I know is that's the parent image. The first thing you want to do is look inside the parentheses. This is a -2, so we talked about -2. I'm going to go ahead and do its first translation. I'm going to do the translation first, and then I'll do the reflection. So because it's -2, I know that that -1 is still right here. Okay, I'm going to do that last. I want to do the translation before I do the reflection. So what I'm going to do is I'm going to do it in red. So I need to go over 2. The vertex has translated 2 units to the right and then up 2 units right there. Okay, and I know I'm just going to draw its parent, okay, over 1. It's all about from the vertex, over 1, up 1, over 2, up 4, 1, 2, 3, 4, over same thing. Okay, because here's my new line of symmetry for my parabola. Okay, because it's 1 away and then it's 2 away from the vertex line of symmetry. So my parent function, after I translate it to the right 2 units and up 2 units, will be sitting right there. But now we have this -1 here. Just like in the previous example, you're going to take this parent image, or excuse me, this image, and you're going to invert it or flip it over its vertex. So now I'm going to do it in blue. Same thing. It's going to start at 0, 0. It's going to start at 0, 0, and instead of going up over 1, you're going to go to the right and then down 1, down over 2, and then down 4. Same thing, down over here and then down over 2 from the vertex, 2 to the left, and then down 1, 2, 3, 4, and you can keep going over 3, okay, down 5, 6, 7, 8, 9. Same thing over here, and it's going to be a upside down image. It just flipped over its parent function or its new translation. So in review, what happened was we had the parent function sitting at y equals x squared, which is the black. And then based on my set of instructions, -2 means I go to the right 2, +2 on the outside, I go up 2, and I draw its image. And then I notice that there's a -1 right here, which means I need to flip it. So if you really want to see its final product, it should look something like this, just the one in blue. That is my final answer. That is how you would graph y is equal to -1 times the quantity of x minus 2 to the power of 2 plus 2. That will be its image. Okay, last example, you just need to write an equation for this. Again, first thing you want to do is write the parent image. So I know that this is y is equal to the power, y is equal to the power of x. Excuse me, y is equal to the absolute value of x. So my parent image used to sit right here. I'm just, when in doubt, draw the parent image to help you. Okay, I know it's going to be a V. Okay, but it has moved to the left 1, 2, 3, so right away. So ignore this formula. This formula is just the general vertex formula. This formula is, remember, you can change these parentheses and the square to an absolute value if you want. This is just a general formula. Y is equal to, I know that it has been reflected, so there's got to be a negative right there. But x, it went over 1, 2, 3, so that's x plus 3 because it's typically the opposite of what we usually do. But think about it. What number do I have to put in for x so that it moves back to 0? I have to put in a -3. So it would go over a positive. So it would be +3 in here because of that -3. And then it actually hasn't gone anywhere. It hasn't gone up or down. There's no vertical translation. So my final answer is y is equal to -1 times the absolute value of x plus 3, or like I just wrote, y is equal to negative absolute value of x plus 3. Okay, and that's all I have. We'll talk about stretch and shrink, scale factor of parent functions in class. Okay, guys, so make sure you guys Might have to rewatch this one more time and then copy down the examples and then we'll go over in class. Thanks, guys.